Lesson 17, acids and bases. So here we have two water molecules, and we know, we've studied water before, and we know that water has an oxygen. Each water molecule has an oxygen and then two hydrogens, right? And the oxygen hogs the electrons from the hydrogen. So the oxygen side of the molecule is negative, the hydrogen side is positive. And this results in water molecules being attracted to each other, because the hydrogen of one water molecule, so let's look at this other little water molecule here, it has two H's and an O. The hydrogen of one water molecule, which is positive here, is going to be attracted to the oxygen of another water molecule, right? We might draw that again up here, an oxygen and two hydrogens, an oxygen and two hydrogens, and then there's also a weak bond in between the hydrogen of one water molecule and the oxygen of another. And you're going to answer in the video questions, what do we call that bond? Okay, coming back. If you said we call that bond a hydrogen bond, you are correct. And so most of the time, that's how water molecules, when water's in a liquid state, are connected by hydrogen bonds. But they break easily, right? And then they reform all the time, breaking and reforming. Now, sometimes this hydrogen here will actually break off completely and bond with a covalent bond to another oxygen molecule and another water molecule, to the oxygen on another water molecule. Then what we have is we have H3O plus, because now this oxygen has three hydrogens bonded to it. And the hydrogen left its electron behind with the previous water molecule here, right? And so now that water molecule is missing a hydrogen, so it's just OH. It just has one H, one hydrogen, but it's negative. It has, because the hydrogen that left its electron behind. And then because we added this hydrogen here, but it left its electron behind, this becomes H3O plus. It has a positive charge. And we call this, we should write this in your notes, this is called the hydronium ion. Hydronium ion. Now this happens if you have, say, a glass of water at room temperature, then it's only about 2 out of every billion water molecules that have done this, what's called self-ionization, where a hydrogen is popped off of one water molecule and joined another. And we see this little sign here. We see a forwards and a backwards arrow, meaning that that hydrogen does not stay there really forever, right? It's going to actually go back to its original water molecule and then become two waters again. So it happens in the forward direction, becoming hydronium and then hydroxide. So let's also write that in our notes. This is hydroxide ion. Right? And it's called an ion because it has a charge. And then it will reverse itself. It will go back again to becoming two water molecules. Sometimes this self-ionization reaction, it's called self-ionization because water's becoming an ion all by itself, becoming two different ions, right? Sometimes it's the self-ionization reaction is written more simply as just one water molecule losing a hydrogen and then being left with a hydroxide. And so, but in reality, that one hydrogen does not stay by itself. It actually will join on to another water molecule to become H3O plus. But it's often written this way as a simplified version of self-ionization. So now let's talk about acids. What defines an acid? Well, acids release hydrogen ions when they are dissolved in water. So here's an example. Hydrochloric acid is a strong acid. It's actually the acids that is in our stomach that helps dissolve our food, so it naturally occurs in the human body. hydrochloric acid. Here it is, HCl, hydrogen and chlorine. There's a little chlorine. No, wait, sorry. The little guy is the hydrogen, and then the big atom is the chlorine. And then, of course, we have water. And so that hydrogen is going to pop off of the water. It's going to release the hydrogen ion, and it's going to join the water and then become hydronium. So here we have a water molecule with an extra hydrogen atom. And like we saw before in self-ionization of water, that hydrogen leaves its electron behind, making the hydronium positive, and then the chlorine has an extra electron because the hydrogen left it behind. So the chlorine just becomes a Cl- ion. And remember that these symbols, AQ means aqueous, it means dissolved in water, L is liquid, and G is gas. Okay, so let's try another one. Your turn. This is hydrogen fluoride, hydrofluoric acid, and similarly, it has a fluorine and a little hydrogen, and we can see from this arrow indicates that that hydrogen is going to join the water, right? And then it's going to leave behind this fluorine, and it's going to leave its electron behind. So what you're going to do in the video questions is you're going to write, what are these two things? What are these two species, we might call them? What do we call them? Okay, coming back, if you called them the H3O plus, hydronium, and F minus, fluorine, then you're right. That is what they are. So that is hydrogen fluoride is an acid because it releases hydrogen ions when dissolved in water. It has a hydrogen ion that pops off and joins water to become hydronium. Bases are the opposite. Bases remove hydrogen ions from water or from a solution. So here's a base, sodium hydroxide. There's a two-step process. First, sodium hydroxide is added to water and it ionizes, becoming sodium ion and hydroxide ion. Then that hydroxide ion, in step 2, that hydroxide ion is going to combine with free hydrogen ions in the solution, in the water. And what do we think that makes? If we have an OH minus and an H, they're going to combine together to make H2O, water. Now, in reality, there are no just free hydrogen ions floating around in a water-based solution. All those hydrogen ions have actually added onto a water molecule to become hydronium. So this is kind of the simplified version of what's going on. But in reality, it's actually the OH minus is combining with an H3O plus hydronium, and that hydronium, that one hydrogen from the hydronium is going to go join the hydroxide to become a water molecule. And then the hydronium is left with only 2 hydrogens and 1 oxygen. So now we have two water molecules. Okay. Now your turn. Okay. So we have potassium hydroxide. K is potassium. Step 1, it ionizes. And then you have to write what's happening in step 2, OH minus. And you're going to write the equation for what's going on. How is it going to remove hydrogen ions from a solution? So that's a question in the video. If you wrote this, H plus goes to H2O, you are correct. Or this is also an acceptable answer if you wrote it joins with hydronium to become 2 water molecules. All right. Very nice. Okay, here's another, and so that's also a base because it removed hydrogen ions from a solution. So oftentimes you'll see bases have the hydroxide ion as part of their formula. Here's an example of a base, ammonia, NH3, that does not have hydroxide. You might look at it and think, oh, well, that's probably an acid. Look at all the H's it has. It could easily release a hydrogen ion in solution, but that's actually not what happens. It's kind of interesting. What goes on is these electrons right here, these are free electrons, unbound electrons. They're very negative because they're electrons. And so they're actually going to attract a hydrogen from a water molecule. And so we could draw our little water molecule here, right? And so that hydrogen is actually going to be attracted and form a bond with that nitrogen. And then what we're going to get is NH4 plus. So we could draw that as NH4, right? And of course it leaves its electron behind with the hydroxide. So we could write that up here. And so that is a base because it removed hydrogen ions from a solution, right? It took hydrogen and bonded it, right? We could also write that as NH3 plus hydronium, right? And then that extra hydrogen goes on there. However we write it, it's still the same effect. It's absorbing hydrogen ions, removing them from solution. Okay, so that is it for this video. We'll do page 2 in the next video.